Okay, today we're talking about personal protective equipment. We abbreviate that as PPE, so sometimes you'll hear it that way. As you see in this picture, the boss isn't protected, everybody else is. Well, hopefully it's just a training exercise. But so this means things like hard hats, eye protection, ear protection, gloves, safety boots, fall protection, and respiratory protection. So in general, we're just looking at it in a general way here. So under the construction standards, they organize these things by a little bit different way than they will under the general industry standards. They start off dealing with foot protection and then head protection and hearing, face protection, and so on. You see with the construction standards, they always start off with 1926, and there'll be a decimal place and then some numbers. And they're numerical, they count upwards. It's not like in math, 0.95 is not bigger than 0.100. They're counting upwards like page numbers or section numbers. But so yes, that describes head protection to have 1926.100, and then 1926.101 is hearing protection. So this is common. And then there can be a bunch of other characters beyond there. If you're getting down to the exact line and verse within the OSHA standard, it can have a lot more characters to the right of that number. And then on the general industry side, they start off with here 1910 point something. So it's 1910.133 for eye and face protection. Whereas back here with construction, eye and face protection was 1926.102. So they don't correlate directly, but they are similar topics and they're dealt with similarly, but there are some differences. In general, what happens with these standards is that when you're doing construction work, you can specifically follow the construction standard. But the safest thing that many companies do and many sites will do is to figure out which standard is the strictest and to follow that one so that they're never in trouble. Okay, so that's a little bit about OSHA. But in general, with PPE, with personal protective equipment, first point, many workers are injured on the job because of not using the personal protective equipment. So if you don't use it, it doesn't protect you. You often don't understand all of the possible problems that can come up, and so you got to wear it to be on the safe side. And in general, in the petrochemical industry, in the plants, you will find that you got to wear safety glasses just to smile, just to be there in the plant. And if you're going to actually do any work, then they put on safety goggles, for example. But a big part of safety is planning ahead, and that means having the right PPE on site, having it ready, and making sure people are using it. So the best personal protective equipment is of no use unless you are doing these basic things, regularly inspecting it, properly caring for it, using it properly when it's needed, and never altering or modifying it in any way. Now, just another thing early on here is that you see the pair of red asterisks that you see in these, in the first bullet and the last bullet on this page. That indicates that this could be turned into a test question near you. So regularly inspecting it. I could be asking you a question like, how often should you inspect your personal protective equipment? Well, daily would be the best answer. Regularly would be another answer. But this goes for other kinds of equipment, tools, power tools, hand tools. How often should you regularly, or should you be inspecting it for possible damage? The first time you use it that day. Regularly, daily. So you'll find this question in various forms throughout this course. And then not altering it is an important thing. So you don't snip the tips off your gloves just so you can reach a nail out of your carpenter's pouch. You wear a enhanced grip glove instead. So again, using just the right kind of glove can change the whole nature of your experience with using personal protective equipment. So yeah, we're going to be looking at hard hats first, eye protection second, and so on. So let me go and bring this along to hard hats. There's type 1 and type 2 hats. The type 2 hat would be the most common one, the one with the bill in the front. We can add accessories to these hats. Sometimes if you're going to wear earmuffs, they're not as easy to effectively wear often unless they are attached to the hard hat. That's particularly true with face shields. If you need to wear a hard hat and you need to wear a face shield, then you better have a face shield that mounts to your hard hat so that you can protect yourself. Now, note that this joker in the upper right corner here isn't wearing goggles or glasses as he should. Face shield only protects the face. It does not protect your eyes. Stuff can bounce against your chest, bounce back to the inside of that hood, the face shield, and come back into your eyes. So it does not protect your eyes. Hard hats are classified as G, E, or C by classification. It used to be A, B, C, but now it's instead of A for general work, it's G for general, which kind of makes sense. And then E for electrical. That makes a little more sense than B. But you'll find old timers that still use those older classifications of A, B, C. And C stayed the same. That's for a conductive hat. A conductive hat means it's not going to protect you against any electrical hazards. So generally, that's a bad thing. There may be special kinds of work where that might be useful, though. So, in a computer chip plant where you don't want any chance of static charge. That's particularly true with shoes. Having a shoe that's electrically insulated is normally the best thing, but if you're working on motherboards or computer chips, you might need shoes that actually conduct instead to discharge static charge. Hard hats are mostly made of plastic, like you see the yellow one up top, but there are carbon fiber hard hats that are pretty cool looking, but they're not better protection. They're just cool. They're not better. Hard hat adjustments. You've got a suspension system in your hard hat where you should have at least 1 inch of space between your head and the shell. So you see that's a testable point there with those red asterisks. So 1 inch space above you. Without that suspension system, the hard hat really gives you no protection. You can put that hat on and smack yourself with a wrench on top of your head, and you'll feel that come through the hat pretty well. So you got to have the suspension system installed. They have expiration dates too, so you need to look at the cast-in date of when that hard hat was made. If that date is older than 5 years, you've got to dispose of the hat. Okay, and no homemade hard hats. What's that? Well, that's where I get a chance to show you a funny picture. Okay, that's not a proper hard hat. Safety glasses, goggles, and face shields. Well, for eye protection in general, when there's even the slightest chance of eye injury, you should be wearing eye protection. So check for the Z87 Plus label, the ANSI label. The American National Standards Institute, they have this standard for testing of safety glasses that proves that they are up to snuff, that they're up to specs. And that code is going to be Z87 plus some other numbers. So you should be looking for, depending on what kind of safety glasses or goggles or shield they are. And so Z87 is what you should remember for a test question. And you see that's a testable point too. Welders use very heavily tinted goggles or a hood for protection against extreme light, and particularly the ultraviolet light, but also the infrared light and other intense light. But the ultraviolet light is probably the most important hazard that you protect against. So here's the ANSI standard. Just for interest's sake, you can look back at this presentation to get more detail, but we don't need to know this for any test questions, but it's just giving you an idea what's involved in making real safety glasses. If you don't have that Z87.1 point something standard stamped on the safety glasses somewhere, they're not safety glasses. They're not safety goggles. So goggles, by the way, while I've got this picture up here, of course, give you far better protection than safety glasses. If you're really going to do some work where there's any chance of real stuff flying, if that's a real potential, then you shouldn't just be relying on safety glasses. You should be wearing safety goggles, which make sure that embers, and they need to be installed tight enough on your face so that nothing's going to slip by. A face shield, again, I mentioned earlier, the way you see it in the picture where this guy is wearing it, he's wearing it properly. You've got the goggles on behind that face shield. course, with welding, you've got a face shield of sorts already built into the process, but you want to make sure if you need a hard hat that your welding hood is also going to be able to work as the hard hat. You shouldn't have to pick your poison of what you're going to allow the risk to be. You should be wearing the right kind of PPE that protects you from everything that you need to protect yourself from. So here's some fancy welding helmets. And so if you need to wear a respirator and you need to wear a welding helmet, you need to wear a welding helmet that is also a respirator. Not like this guy. Okay. Bad picture. Okay. So eye and face protection, you're just talking about some of the different things in here, but let's move on to safety harnesses. A safety harness in general, we have a basic fall protection rule in construction of 6 feet. So it says here, a safety harness should be used when working more than 6 feet above a surface. So that's a very basic, simple basic rule about fall protection. We have the 6-foot rule for construction. If you're following the general industry standard instead, if you're not doing construction, then it's actually 4 feet. So we have less strict rules in construction. So the 6-foot rule is the one that I would ask you about here, because we're focusing on construction here. Now, yes, there's a whole bunch of language in here on this page for fall protection. It's meant to be a reference for you. Some of this stuff I will describe as we go, because some of it's important, but and we'll look at some of it in more detail as we go to other chapters, other sections. But in here, yeah, for instance, there's something called a body belt. A body belt is a strap, it's a hoop. Well, it's not real fall protection, but it is under the classification of fall protection. But you cannot use it for fall protection anymore. Not since 1997. Yes. Okay. So let me click past that and let's just looking at some of these things as we go here. Here's a drawing of a guy wearing a safety harness. So a safety harness has straps, pelvic straps, crotch straps or pelvic straps that need to be tight enough that you can't get any more than 2 fingers underneath the strap. So they can't be loose or they're not going to do their job. Your waist strap or a chest strap or both need to be snug enough. It's the same thing, that you can't comfortably get more than 2 fingers underneath your strap. So the safety harness, you wear that thing and that's good, but then you need to be attached to something. And so we generally attach to a lanyard, that D-ring that you see on the back up between the shoulder blades. Needs to be up high enough in the shoulder blades so that you're above your center of gravity. And that's what you tie off to connect to a lanyard. And then the lanyard you tie off to some kind of a tie-off point, or maybe a rope grab, or to a self-retracting lifeline. So there's a couple of pictures of a safety harness, and then a pair of 2 different kinds of lanyards. So you want to use the shortest lanyard that'll do the job, because you really don't want to fall very far before this thing starts slowing you down in your fall. So the free fall distance, you need to limit that. OSHA says that you have to limit that to no more than a 2-foot free fall. So you can't have a long lanyard that's going to allow you to fall 30 feet and then come to a stop. It's going to be a tremendous blow to your body. The other thing you see in these 2 pictures of the lanyards is that they've stitched up a bundling of that webbing. That synthetic strap is stitched together into a bundle there at one end on purpose, so that as you fall, it'll decelerate you. It'll slow you down, arrest your fall by unstitching itself, which means then when that stitching has come loose, you've got to take it out of service. That one has been spent. Now, for suspending, if you're these harnesses, the ones we normally use are Class 3 harnesses, and they are only allowed to be used for a single use of a fall. So you don't fall and use it again after that for a different protection. No, once you've actually fallen with these, you've got to take them all out of service. However, there is something that's more of a boatswain that you can sit in, like you see in this picture. That's considered a Class 4 harness. They can support your weight while you work. And what happens is you have a lifeline that is a line that's supporting your weight, the load line actually, and then the lifeline is there for the emergency. And so you can see that these two are actually tied with one with taking the load, and the other one is for the emergency use. There's a couple of things I can see wrong with this picture. The guy on the left dangling should have that rope grab up higher. It should always be tied up above you, not below you, because that means that he would fall a lot further than 2 feet. The third guy up at the top on the roof looks like he doesn't have one of maybe his chest strap connected for himself as he's up there. But anyways, here, this is a much worse situation. He is tied off, and that's better than sometimes you have on residential sites. But of course, his plank scaffolding system, OSHA would freak out about. But you see what he's tied off to. He's tied off to something inside the house, underneath and inside, going in that window. And this picture shows it better. That lanyard is going down instead of up above him like it should. So he's going to fall quite a ways. Also, that's not likely safety glass. So when he falls, he's going to yank that glass out, and he'll have shards of glass raining down upon him. So that won't be good either. But as far as fall protection is concerned, he's going to fall a lot more than 2 feet before the system starts slowing him down, and he'll slam against the building too. So that's not particularly good. His buddy on the other end is in worse shape, though. He's got that white rope that you see here, and that's attached to his lanyard. He'll probably hit the ground before it does anything. And you're supposed to be tied off to something that can support 5,000 feet. 5,000 pounds per worker attached. So there's that 2x4 poking out that that white rope is attached to over at the left. Does it look like that can support 5,000 pounds to anybody? Not likely. And both guys have the same nail gun technique here. But anyways, yeah, these are OSHA file photos, the ones with the black squares in front of their faces, because they didn't get their permission for taking these pictures. But OSHA does show up on residential sites. There's so many of them, they're just not going to catch everybody like this. Oh, here's another site where they're showing up and they're catching people at something here. So that's an OSHA file photo. No sky hook, so they're making one, hey? Okay. Yeah, and of course, we have some more fun pictures here. But again, fall protection. We'll look at that in a lot more detail coming up, later in another topic. Gloves. Never wear cloth gloves. It's not a good idea to wear them really anywhere that you're doing work, but they're not very safe. They act like a tourniquet, and so around rotating or moving equipment, if it gets hooked on them, they can yank off fingers or hands. They can work like tourniquets. And so normally a real safety glove is made of leather, and it can have some canvas on the back. But the idea is it's designed to tear away instead of tearing away fingers. Whereas you get a garden glove, the garden glove with the cloth going all the way around will act like a tourniquet, and it can tear up skin. I can tell you, I know I had a student that showed me the scars in his hands from having 15 stitches because he had a 12-volt, or no, 18-volt DeWalt drill that he was putting in or taking out a bit, and he was using his hand with the cloth glove on, and it tangled up around that shaft of the chuck of the drill, and gave him enough serious cuts of tearing the flesh off of his fingers that he needed 15 stitches. There's other specialized gloves. Nitro protects against solvents and harsh chemicals. Butyl provides a real high protection of permeation of gas and water vapors into the rubber. So that's another type of material. Kevlar can protect against cuts and slashes and abrasion. And then here, where they're cutting meat, for sanitary reasons, they're using stainless steel mesh on one hand, the hand that's touching the meat. So there's a lot of specialized gloves out there for special jobs. The welding gloves that a welder would use are much thicker leather. They're much longer and bigger so that to prevent the embers from getting inside the cuff of the glove. There's heat-resistant gloves. Well, the welding gloves are somewhat heat-resistant too, but there's other ones that are even more resistant to heat. There's electrically insulated gloves that welders would use, that electricians would use, that protect them from being electrocuted when they're working on high voltage electricity. And with those gloves, they're very fragile, and so they'll use a thin leather glove over top of the rubbery electrically insulated gloves to protect them, because you can't have any flaws in that rubbery glove at all. There's vibration reducing gloves that give you padding, which, gosh, they would have really helped when I was a kid running a jackhammer. If I had padding, I had to invent my own by taking a glove on top of a glove on top of a glove, and it didn't help. It helped a little bit, but so getting the right, being aware of what right tools are and what kinds of specialty PPE are available could help increase production on your job site because of having just the right tool. Personal protective equipment they are tools. Enhanced grip gloves could make it easier for you to pull that nail out of your pouch when you need another nail out of the carpenter's pouch. So if you get enough bandages, well, maybe you don't need gloves, right? Well, no, you need gloves. Now, this next picture is a little gruesome. You don't have to look at it, but I want you to, for those of you who can stand to look at this gruesome picture, it's called degloving, before I show it to you, where your ring can hook on things. So when you're wearing a wedding ring or any kind of a ring on your finger, when you're doing rugged work outside or any kind of work that's physical, you should take your rings off. You shouldn't be wearing jewelry of any kind, really, with you. Any piercings will get yanked upon in construction. They can happen, catch on you. So yeah, brace yourself for this picture, but here it is. This is called degloving. Now, this guy didn't lose his finger. It's stitched on, but stitched back on again. It's salvaged, but it's an ugly wound and probably means numb finger for the rest of his life. And then this next picture is showing jewelry being yanked from ear piercings and stuff. So that's okay. So that's enough of the gruesome stuff. This is just showing you a series of pictures where they're testing the rubbery glove that an electrician could wear to protect himself from being electrocuted. And what they do is they literally inflate it. They look it over carefully, but they inflate it with air to look for air leaks, because even a little air leak can allow an electrical charge to find its way into electrocuting you when you're working like that. Okay, now to safety boots and safety shoes. The best boots and shoes for construction sites are steel-toed and steel-soled. And so that means you got steel toes and you got a steel shank in the sole of your boot, so that when you step on a nail or sharp rebar or sharp mesh, it's not going to come right through the bottom of your sole of your foot and still get you. So the trouble with steel-soled shoes or boots is they're harder to walk around on because they don't flex as much. So most of the steel-toe boots that you buy at a lot of stores, a lot of the common ones and affordable ones have no protection for the bottom of your foot. So just realize if you're on terrain and job sites where there can be nails poking up, there can be sharp objects like rebar sticking up in mesh, which is a lot of job sites are like that, then you better have better protection than that. A steel-soled boot or shoe actually makes it easier to stand on a ladder, by the way, because it is not so hard on the foot. If you have to stand on a step ladder for a while, a steel-soled shoe is actually a good thing. But what you see in this last bullet, never wear canvas shoes or sandals on a construction site. They're not enough protection. You need the leather, or you need some high-grade synthetic materials, as they have in some of these work boots now. But traditional leather is a very good, durable material for dealing with, for a work boot. And a high-top boot gives you better protection with your ankle if you're on rough terrain. So yes, and maybe if you're indoors all the time with your work, a lower top steel-toed shoe would be fine. But rough terrain, you need that ankle support. Hearing protection. Another aspect of PPE is having protection for your hearing, to protect your hearing. So noise-induced hearing damage is most often painless, and it's not noticed, and it's a chronic effect, meaning it happens over years. So a lot of times employers don't spend a lot of energy protecting people from hearing loss because it's hard to prove where you lost your hearing from. So they're not too worried as long as they've provided you a bunch of earplugs, whether you wear them or not. Well, those days are changing. That at some point, your workers can come back many years after they stop working for you to have your company pay for their hearing aids. So, think about this from the economic standpoint of protecting your company, but also about protecting your workers. Make sure that they are wearing proper hearing protection. That means earplugs and earmuffs. Now, I know the earplugs here in Louisiana heat is miserable. So the earmuffs are, not ideal. They work great in cold weather to keep your ears warm, but sometimes they're still the best thing to use, even here in Louisiana. If you need to put on hearing protection and take it off and on and off and on and off throughout the day, the earmuffs are better because you can put them on briefly when you're making the noise and then take them back off. The earplugs, if you have to keep putting them in and out of your ears, you're going to have a sore ear canal after a day or so. So they don't work too well. It takes a long time to get a good fit, a good seal with an earplug. Yeah, it's just ear candy doing nothing if it's not installed properly. If you can still hear a lot of sound, then it's not. If it's not reducing what you hear, then it's obviously not working. And all it takes is a little crack, a small crack. That's where it's not sealing, and it's not doing anything for you. And sometimes, if the noise is loud enough, you might need to wear both earplugs and earmuffs, or a higher caliber, higher quality earmuff to protect yourself. Now, we measure sound in terms of decibels, but it's not a linear scale. It's a logarithmic scale. And what that means is it's a very flat scale as far as when you're looking at 90 decibels and 92 decibels of sound, there's 10 times more energy in 92 decibels as there is in 90 decibels. So there's a lot more energy as you go up this scale. Now, OSHA has some fairly pathetic standards when it comes to protecting workers from noise. And so they say if you got 8 hours of a continuous exposure to 90 decibels, then you have to be protected. So we have a threshold limit value at 85 decibels. If you have an average rating throughout the day of more than 85 decibels, when you're measuring throughout the whole day, the time-weighted average, well, that's when you're supposed to start using hearing protection. Meanwhile, if you get down to 115 decibels, or down, I should say up, it's louder, much louder, and a lot more energy involved, then even OSHA says you should not experience any more than a quarter of an hour, 0.25 of an hour. Well, that's a strange way of writing it, but this is often how they do. And it's the same as 15 minutes, but it seems a little strange to write it that way. But just beware of that. So yeah, double hearing protection if you're anything over 105 decibels of energy. Hearing protection is generally needed once you go above 85 decibels. So here's the bullet. The second bullet on this page says, everything's about this on this page. When must hearing protection be provided? And the second bullet says, when an employee's noise exposure exceeds an 8-hour time-weighted average, or TWA, time-weighted average, sound level of 85 decibels. So there's a couple of numbers there. 8 hours. It's a time-weighted average, or TWA. So those are abbreviations to remember. But 8 hours, and when it exceeds this 8-hour time-weighted average of 85 decibels, I guess the most important number there is the 85 decibels. Yeah, okay, so now respiratory protection, where there is a danger of suffocation or breathing toxics, or there's flammables that can also be toxic, that you need a respirator. So that means there's respirators that are used for dust, and respirators used for filtering out fumes. So if all you need is a filter to filter out that stuff, if there's enough oxygen in the space, then you can use an air purifying respirator that has filters. So that's what we call a respirator with filters. It's called an air purifying. It's purifying the air, but there's not supplying any oxygen. So if you don't have at least 19.5% oxygen present in the air, that means you have to test for it to know that, then you shouldn't be using an air purifying respirator. You need to use a supplied air respirator of some sort. And these things shouldn't be shared. Of course, you'll spread germs and such. But anyway, so here we have 4 different kinds of respirators. Well, at the bottom, we've got the air purifying respirators. The one on the left at the bottom is a full face mask, and then the one at the right is a half mask. If you've got something that you're in the air that's not bothering your eyes, if it's not intense enough to bother your eyes and not affect the eyes, then a half mask is fine. Otherwise, you need to wear a full mask in order to give yourself protection. But if there's not enough oxygen, then that's not going to help. Oh, and if you don't have the right kind of filters in there, it's not going to help either. If you got to worry about asbestos or silica or some other sort of dust, then you need the dust filters. But if you've got a paint fume or lacquer thinner or some kind of fume, then you need a different kind of filter that can deal with fumes. That's a much tighter particle size filter. If you don't have enough oxygen, then you need to move up to one of these respirators you see at the top of the page. The one on the right-hand side is called a supplied air respirator, or sometimes abbreviated as SAR. So a supplied air respirator has a hose attached that's supplying air from some source. And so you got strings attached. Whereas the one at the right is an SCBA. We sometimes call that scuba, but it's not a scuba tank. Well, those scuba tanks kind of are in there. But SCBA, self-contained breathing apparatus, is what it stands for. So this is something that a firefighter would wear, but this gives you but certainly even on a construction site, this allows you to move into a space without worrying about your hoses getting tangled or hooked on stuff. And you're self-contained, so whatever oxygen you have is what you have. With the supplied air respirators, most of the time, or the guy in the red shirt, they mostly use. Also, a best practice is to have an emergency tank, a little bitty tank on their hip that holds about 8 to 10 minutes of air so that you can escape if something goes wrong with your air supply. And that's not a respirator. He's trying, but it's not going to work. Okay. So one of the things we have to worry about with a respirator is making sure you have a good fit. So your respirator has to fit snugly enough against your face to get a good seal. And that means having a proper fit test and check. The positive fit check, you block the exhalation valve and breathe out positive air pressure inside the mask. Negative fit test is usually, and the fit check is more useful, and that is where you block the inhalation valve and you suck air in. You suck towards, and what you do is you're testing for leaks, because that's usually where the problem runs. If you can suck in air and get some air from outside air past the seal, then that's a problem. Oftentimes when you're doing a test or a check, they'll use smelling salts, and if you can smell them, it tends to straighten your backbone. Backbone, and it's hard to kind of fake that. And that way you kind of make sure that the person is well fitted. But here's the thing: if you crank down these masks too tight, you'll get a headache in a matter of about 15 minutes. You'll have a migraine headache that'll make you have to give up for the day, go home and rest. So you have to get them snug enough to be sealed, but not any snugger, because there are muscles over across the top of your head that will ache like crazy, and it tends to turn into a massive headache. Okay, so then the cartridges on the air purifying respirators have to be cleaned. They need to be replaced. Cleaning them is problematic. From a distance, you could blow dust off of stuff or wipe dust off of them with a rag. But taking an air compressor and blowing through them, you can punch holes through the filter. And that's the same as not having a filter at all once you've got holes in them. This happens with people with cars sometimes. When they're doing maintenance, they'll blow the dust off of their air filter for the engine and end up ruining the engine because you're letting dust particles into the engine that are getting past the filter because you punched holes in it with They're maybe not something you can see, but big enough for particles of air, of dust to get in. We said the old Model Ts were good for about 10,000 miles before they needed an engine rebuild. That's because they didn't have air filters or oil filters back then. Okay. This guy's blowing all kinds of silica dust all over the place. And so he should be wearing a respirator. He might be, I can't tell in this picture, but anybody around you needs to be wearing a respirator. So you're no longer allowed to do this. It used to be allowed in some cases until about 2015. OSHA really clamped down on the silica exposure in construction. It was already pretty strict for general industry, but it's become strict for construction too now. You have to vacuum the stuff instead of blowing the dust out of the cracks and stuff before you put in caulking. Running a concrete saw, you get rid of some of the dust because you have a water blade, water on the blade to keep the blade cool, and it removes dust. But there's always dust to remove, and so that gets beyond that. And so, this picture probably should be in another place, but this guy fell on his framing nailer and accidentally countersunk a nail into the roof of his mouth, and it went up behind the eyeball, but missed anything important. So he thought he had a toothache and went to the dentist. But anyways, so here I have a summary at the end here, and I do that in a lot of these presentations. At the beginning, I have a list of the OSHA standards that are applicable, and at the end here, I've got a bit of a summary. So personal protective equipment is most effective when it is inspected regularly, properly cared for, and used properly. These are all things that I mentioned in here. All these categories. Oh, and knowing that, class G, E, and C, what they stand for is as far as protection hard hats. G for general work, E for electrical work, C for a conductive hard hat. Those kinds of things. The Z87, make sure you know that number. And the safety harness has a D-ring that should be attached to one end of a short section of webbing or wire rope called a lanyard. Okay, well, there you go. The other end of the lanyard should be tied off to something that can support at least 5,000 pounds for each worker attached to that tie-off point. So those are things I've said in here, things that'll come up again and again in this course, more than once anyways. Anything else? I'm looking for numbers. You see, that's the thing, is you can reason out a lot of this stuff. It's logical. But if you forget that 85 decibel number down here at the bottom, the last bullet, it says, according to OSHA standards, when an employee's noise exposure exceeds an 8-hour time-weighted average sound level of 85 decibels, then hearing protection must be worn. And remember, air purifying respirators, for them to work properly, there must be at least 19.5% oxygen present. Those are numbers. So that's the thing to really watch. Now, when you do the quizzes, you're going to have a great chance to see all of this stuff in action in actual test questions. And so it's good to do the quizzes and do them more than once, as I've said before. And I guess they needed some kind of PPE here, some kind of protection for the head, and maybe the tail in this case too, huh?